Okay, so example 2, we're going to take a look at another system. This time it's just an algebraic system. There's really no context given to these lines. They're just algebraic equations that create a system and we're going to solve for. Okay, so we have 2x plus y equals 2 and x minus y equals 7. We're going to find the solutions using our graphing calculators. And again, the important thing to remember here is that when we're asked to find the solution, we're looking for the intersection points between these two lines. So to put these equations into our calculator, what form do they need to be in? Right now they're in general form, but I need them in a special form so that I can put them into y equals in my calculator. Well, slope-intercept form would allow me to do that. So I need them in slope-intercept form. Okay, so let's go ahead and do that first. 2x plus y equals 2. Converting that into slope-intercept form, we're going to bring 2x over. So we get y equals negative 2x plus 2. And then the other line, x minus y equals 7. Turning that into slope-intercept form, I'm going to bring the x over. So I have negative y equals negative x plus 7. And then divide everything by negative 1, giving me y equals positive x, because negative divided by negative is positive, minus 7. So these two equations I'm going to graph into my into my calculator. Okay, so let's graph this. Go into y equals, and let's graph negative 2x plus 2 and x minus 7. And just the standard window settings will suffice, so zoom 6. There's our intersection point. And to find it, we go second trace, number 5. Enter, enter, enter. And here's our intersection point, 3, negative 4. And again, I just want to draw special attention to the fact that our solution is the point at which these two lines cross. And they are the same point, the same value, only at that point and nowhere else. Okay, so let's verify that our solution is correct. We have the solution 3, negative 4. Let's check to make sure that's correct. How would you verify that 3, negative 4 is a solution for these lines? How do you prove that a point lies on a line? Well, if you remember from the last chapter, what we did is we took the x-coordinate and put it in for x in the equation. We took the y-coordinate and put it in for y in the equation. And if the left side balanced out and equaled the right side, then we knew that that point lied on the line. And if it didn't balance out, then that point wasn't on the line. Okay, so I need to take the x and y coordinates for this point and put it into x and y for this line. Should I do it for the other line as well? Well, you have to think about that. You need to prove that this point lies on both of these lines. So because of that, we're going to have to put this point into both equations to show that it satisfies both equations, to show that it lies on both lines. Okay, so let's verify first for 2x plus y equals 2. I'm going to put in 3 for x and negative 4 for y. Will that equal positive 2? Well, that gives me 6 minus 4, and that does in fact equal 2. So left side equals right side. We know that the point 3, negative 4 lies on 2x plus y equals 2. Now let's verify x minus y equals 7. So again, I put in 3 for x, negative 4 for y. 3 minus negative 4 is 3 plus 4. And that does indeed equal 7. So I've verified here that the point 3, negative 4 lies on both of my lines. And again, to verify properly, you have to check the point in both lines. If you only put it on in one equation, you've only proven that that point lies on one of the lines, but we don't know about the other one. So you have to prove it for both lines.